Okay, this is Math 261 on Section 11.4 on the cross product. And this is going to be Part 5. In Part 1, we talked about the formula for the cross product of two vectors based on a matrix or grid way of calculating and remembering what to do. We have three terms in parentheses here that come from the diagonals going down this way. And then we have a minus sign, and then another set of parentheses, and those terms come from the diagonals going down this way, with pluses inside the parentheses. And that's a way to remember and carry out this formula. In the previous parts, we did some examples of that. We talked about the geometry, that the cross product of two vectors is orthogonal to each. And we talked about some algebraic properties of the cross product. These are going to be useful to us in this part. Not 100% necessary, but they will save us some work, so they're worthwhile. In the previous part, we also did this example where we found that the cross product j cross I was negative k. And I just want to point out the orthogonality property surely holds there, because k, the cross product, is definitely orthogonal to both I and j. Negative k. I'm not sure I said negative there. Negative k is orthogonal to I and orthogonal to j. Now, in Part 5 here, we're going to start with example 2. So the first thing we have to do is u cross v for these two vectors. And there's no shortcut to that. We just have to work it out. So on the right-hand side, highlighted in the bluish color, I've written the component forms of these vectors. 3, 0, 9, and 3, 7, negative 6. And I've set up the grid for the cross product, so we need to do the calculations here. U cross v is going to be, down the first yellow diagonal, we'd have 0 because of the 0 here. The second one would be, so I won't write the zeros. The second one would be 27j. The third yellow diagonal would be plus 21k. And then we have a minus, and some more terms coming. And then the terms that come from the bluish diagonals going from upper right to lower left go in the second set of parentheses. The first one of those is 0, k times 0 times 3, so I won't write it. And then we'll have 63, 9 times 7, I. And then we'll have negative 18, negative 6 times 3 times j. Okay? And this would be 27j plus 21k minus 63i, and then plus, from distributing this, negative 18j. And that would mean the cross product is negative 63i plus 45j plus 21k. In component form, that would be negative 63, comma, 45, comma, 21. The i's and the j's and the k's don't go in the angle brackets. The angle bracket way, whether it's x, y, or z, is kept track of by the position. The i's, j's, and k's are the unit vectors, and obviously when we're working this way we have to include them. They're very important, but in the brackets we put the coordinates in order. Now part B, that was kind of a side comment, because sometimes for whatever reason people start like putting 45j in the brackets, but no. Now v cross u, we could do the same kind of way. We would have to switch these two columns, if you think about it. But we have the algebraic property back neat here. Number one, u cross v is negative v cross u. Now how that applies here is like so. Here we have v cross u. So that's going to be, it's not u cross v, but it is negative u cross v. It's kind of a cool property. It says you can switch the order of the cross product, but you have to change the sign when you do that. So the answer for B, using that property, no real work involved, would be negative what we have up top. Probably trying to squeeze in too much here, so and that would be change all the signs inside. 63, comma, negative 45, comma, negative 21. That vector would be the answer to part B. I didn't really intend to do all the work there. I was too squeezed up, but what you're doing is changing all the signs in v cross u to get u cross v, which is always kind of fun, I think. I know, depends on your definition of fun. Now, the reason I'm scrolling back up here is because property 5 is going to come into play. A vector cross product with itself is equal to 0, the 0 vector. So that's what we have in C. So really, C straight away is going to be the 0 vector. And that can be expressed in component form that way, or in IJK form, 0I plus 0J plus 0K.